6th grade, Module 6, Lesson 8, Classwork, Variability in Data Distribution. Robert's family is planning to move to either New York City or San Francisco. Robert has a cousin in San Francisco and asked her how she likes living in a climate as warm as San Francisco. She replied that it doesn't get very warm in San Francisco. He was surprised by her answer. Because temperature was one of the criteria he was going to use to form his opinion about where to move, he decided to investigate the temperature distributions for New York City and San Francisco. The table below gives average temperatures in degrees Fahrenheit for each month for the two cities. So we have New York City and the temperature for January, February, all the way through December. And then we have all of the average temperatures in San Francisco for those months as well. So exercise 1 says, use the data in the table provided in example 1 to answer the following. So first we're going to calculate the mean of the monthly average temperatures for each city. So let's start with New York City. I'll say New York City, and then we have San Francisco. So remember, what we need to do is add all of them together and then divide by how many there are. So we're going to do 39 plus 42 plus 50. I'm just listing all of them. So we're going to take all of those, and then we're going to add them together, and then we're going to divide by, there's 12 months. So let's do that. So we had 39 plus 42 plus 50 plus 61 plus 71 plus 81 plus 85 plus 84 plus 76 plus 65 plus 55 and plus 47. So we add all of those together, and all 12 months together are 756. And let's divide that by the 12 months to find the mean or the average temperature. So the average temperature there is 63 degrees Fahrenheit. So now let's do San Francisco. So San Francisco, we would have 57 plus 60 plus 62 plus 63 plus 64 plus 67 plus another 67 plus 68 plus 70 plus 69 plus 63 plus 58. And then again, we're going to divide all of that by 12. So clear that out. We have 57 plus 60 plus 62, 63, 64, 67, another 67, 68, 70, 69, 63, and 58. So we get 768. Let's divide that by the 12 months to find our mean, and we get 64 degrees Fahrenheit. So the mean for New York City is 63 degrees Fahrenheit, and the mean for San Francisco is 64 degrees Fahrenheit. So recall that Robert is trying to decide where he wants to move. What's your advice to him based on comparing the means of the monthly temperatures of the two cities? So if you were going to base your move off of these two, I mean, the difference between 63 degrees and 64 degrees as the mean isn't really very noticeable. So if you're just looking at the mean temperature, it wouldn't give you a very good indication of which city you might want to move to. So I'm going to say, since the means are almost the same, Robert could move to either city. I'll just leave it at that. So you might look more in depth and what we're going to talk about in a minute. So you might have noticed that New York City has a much wider range, like goes all the way down to 39 degrees for one average, up to 85 degrees in the summer, whereas San Francisco is a little bit more of a mild climate. So, I mean, the lowest I really see is 57, and then the highest is 70. So if he really just wants to be around 64 degrees all the time, San Francisco is a good choice. If he wants more of a place with seasons, where in the winter it's really cold and in the summer it's pretty hot, then New York City would be a good choice. But that's something we can't tell just by looking at these two numbers right here. So you could expand on that if you wanted to. Okay, so understanding variability. Maybe Robert should look at how spread out the New York City monthly temperature data are from the mean of the New York City monthly temperatures, and how spread out the San Francisco monthly temperature data are from the mean of the San Francisco monthly temperatures. To compare the variability of monthly temperatures between the two cities, it may be helpful to look at dot plots. The dot plots of the monthly temperature distributions for New York City and San Francisco follow. So he plotted the different temperatures, so all the way starting at 39 degrees and up to 85 degrees. So see how they're much more spread out here in New York City, and in San Francisco, they're kind of bundled together here between like 55 and 70 degrees. So it says, mark the location of the mean on each distribution with a balancing triangle symbol. How do the two distributions compare based on their means? So the average for New York City was 63 and San Francisco was 64. So 63 is about right there for New York, and 64 right here for San Francisco. How do the two distributions compare based on their means? So they are about the same. So let's say the means are about the same. Number 4, describe the variability of the New York City monthly temperatures from the New York City mean. So the variability is talking about what we said earlier. So the temperature ranges from 39 to a high of 85, and they're pretty spread out. They're not really gathered around the mean, they're pretty spread out. So let's say the temps vary greatly from 39 degrees to 85 degrees. They are spread out from the mean. Or around the mean. Number 5, describe the variability of the San Francisco monthly temperatures from the San Francisco mean. So the temperatures are kind of clustered here around the mean. So they kind of are all right in that same area. So let's say they're clustered around the mean and vary from a low of 57 to a high of 70. Have a low of 57 degrees Fahrenheit and a high of 70 degrees Fahrenheit. Number 6, compare the variability in the two distributions. Is the variability about the same or is it different? If different, which monthly temperature distribution has more variability? So I would say that the variability is different in the two distributions. Here, it's more spread out in New York City, where it's more clustered together in San Francisco. So let's say the variability is different. New York City has a much greater variability than San Francisco. Number 7, if Robert prefers to choose the city where the temperatures vary the least from month to month, which city should he choose? Explain. So he decides he wants it to be kind of the same temperature all year round. He doesn't want to deal with all the winter clothes and the summer clothes. He just wants kind of the same season all year round. So if we're looking at the place that has the same temperatures most of the time, that would be San Francisco, because he's only going from about 57 degrees to 70 instead of all the way from 39 degrees to 85. So looks like San Francisco would be a best choice for him. So I used to choose San Francisco because the temperatures vary the least there. Example 3. Considering the mean and variability in a data distribution. The mean is used to describe a typical value for the entire data distribution. Sabina asks Robert which city he thinks has the better climate. How do you think Robert responds? Well, if you were just looking at the mean, you would say that they both have about the same mean. But the mean is a better or more precise measure of a typical monthly measure for San Francisco than it is for New York City. So we would say a better or more precise measure of the typical monthly temperature in San Francisco than it is in New York City. Sabina is confused and asks him to explain what he means by this statement. How could Robert explain what he means? So we want to expand a little bit more and say that New York City, the winter months are colder. Let's say in New York City, the winter months are in the 40s, and in the summer the temps are in the 80s. Mean of 63 isn't very close to either of those. Therefore, mean is not a good indication of New York City's monthly temperature. In San Francisco, the variability is much smaller. Okay, exercises 8 through 14. Consider the following two distributions of times it takes 6 students to get to school in the morning and to go home from school in the afternoon. To visualize the means and variability, draw a dot plot for each of the two distributions. So let's do morning. We have 11, 12, 2 14s, a 16, and a 17. And then in the afternoon, we have a 6, a 10, a 13, 2 18s, and a 19. So what is the mean time to get from home to school in the morning for these 6 students? So let's do the morning mean. So we have 11 plus 12 plus 14, 2 of those, plus 16 plus 17. That's equal to 84. And then how many times did we have? 1, 2, 3, 4, 5, 6. So we're going to divide that by 6. So we get 14. So the average time is 14 minutes. The mean is 14 minutes. And then let's do the afternoon time. So we're going to add them together and then divide by the 6 times. We have 6 plus 10 plus 13 plus 18 plus 18 plus 19. Oops. And then divided by 6, we also get 14. Number 11, for which distribution does the mean give a more accurate indicator of a typical time? Explain your answer. So looking here, the average is 14 for both of them, but I would say the morning is where the times are more clustered around 14. Here in the afternoon, it ranges anywhere from 6 to 19 minutes, where in the morning it's only 11 to 17 minutes. So the variability is much smaller in the morning than in the afternoon. Let's say the morning mean is a more accurate indicator the variability or spread in the afternoon is much greater than in the morning. All right, distributions can be ordered according to how much the data varies around their means. Consider the following data on the number of green jelly beans and 7 bags of jelly beans from each of 5 different candy manufacturers. The mean of each distribution is 42 jelly beans. So the mean of all of these is 42. Draw a dot plot of the number of green jelly beans for each of the 5 candy makers. Mark the location of the mean on each distribution with a balancing triangle symbol. Okay, so let's start with all good. So we have 2 40s, a 41, a 42, another 42, a 43, and a 46. So there's all good. The mean of each one is 42. So let's go ahead and mark the mean. I'm just going to mark the mean on all of them. The mean on all of them is 42. Okay, best. We have 22, 31, 22, 31, 36, 42, 48, 53, and 62. For delight, we have 26, 36, 40, 43, 47, 50, and 52. Sweet, we have 36, 39, 42, another two more 42s, 44, and 49. And then lastly, for yum, we have 33, 36, 42, 42, 45, 48, and 48. Okay, so there are our dot plots. Number 13. Order the candy manufacturers from the one you think has the least variability to the one with the most variability. Explain your reasoning for choosing order. Okay, so I'm gonna find the ones that have the least variability. So looks like the least variability would be between like all good, because it only goes from 40 to 46. Maybe sweet and yum. So all good has the least variability because they're clustered between 40 and 46 or 47. So I'm going to start with all good. There's not one right or wrong answer here. All good. Then 2, it's a toss-up between sweet and yum, but I'm going to go with sweet because it has 3 that are exactly the mean. And then I'll make yum number 3. 4 and 5 between delight and best. Best has a greater variability. It goes all the way from 22 to 62. So I'm going to go with delight because it's about 26 to 52. So delight, and then what was that other one called? Best. Best seems to have the worst variability. All right. Explain your reasoning for choosing the order. So I chose, let's see, all good, sweet, and yum have the smallest variability. And delight and best are much more spread out. Number 14, for which company would the mean be considered a better indicator of a typical value based on least variability? So let's look at which one do you think the mean is the best indicator. Well, I'm going to go with who I chose as number 1, all good, because they're all kind of clustered in the same area. It has the least variability. So let's say the mean for all good would be the best indicator of a typical value for the distribution. And that's the end.